Assalamualaikum warahmatullahi wabarakatuh. So today, not today lah. So right now lah, my group will present about first static and rotary inverters, rectifier and transformer rectifier unit. Okay, so I will start with rotary inverters, and my friend Haziq will continue with the static inverters. And Muhammad Nasirul Rahman will present about rectifier, and Muhammad Taufik and Afiq Hilman will present about transformer rectifier unit. Okay, first, rotary inverters. What is rotary inverters? Rotary inverters are largely confined to older aircraft due to poor reliability, excess weight, and inefficiency. Alright, we continue. Okay, inverters were simply special type of motor generators. That is what inverters, okay. It's a constant speed motor was employed to drive an alternator AC that was designed to produce the particular type of power required. Okay, so this is the example picture of the typical rotary inverter. Okay, this is a diagram yang that use how the rotary inverters do not do lah what is this like a diagram of rotary inverter. Okay, the rotary section consists of a DC motor driving an AC generator. The rotors of the motor and the alternator are dynamically balanced and are mounted on the same shaft. Fans are also mounted on the shaft to provide for air cooling. So DC, so rotary inverters ni dia adalah satu gabungan antara DC motor that's driving an AC generator. So meanwhile macam dia digabungkan in same shaft. So when the DC motor works, so the AC generator also works. So why dia cakap dynamically balanced? Okay, the rotary inverter utilize an input voltage of 26 to 29 volt. Output dia is 115 volt single phase, 115 volt 3 phase, and 200 volt 3 phase, and the frequency is 400 Hz for all phases. Okay, the disadvantage of these rotary inverters is heavy. First, it is heavy, require regular servicing and maintenance. Alright, why? Because the maintenance of rotary inverters is similar to that for motors and generators, but maintenance practices are set forth in the manufacturer's maintenance or manual service. Maksudnya dia setiap kali untuk maintenance, we need to check the manual service or maintenance service. Alright, this is the picture of what we call rotary inverters. Alright, static. Actually raja rotary inverters normally it requires a starting circuit to prevent the DC motor armature from overheating at low RPM because of the extent is back EMF is low, so it can be overheat lah. Okay, figures on the right shows a typical T start circuit. The resistor is short as back EMF has built up. Okay, in this picture. Okay, so AC voltage control. Voltage control by varying AC generator rotating field. This is done using carbon pi regulator as shown in the next figure, or transistor control voltage regulator. The AC output is monitored by rectifying the sensed AC voltage and feeding it to voltage regulator which control the field current. So rotary inverters is inverters that is using a manual, like we need to monitor the sense AC voltage, we need to monitor the speed of pusingan dia kan. So that's why rotary inverters are used in all aircraft. But in nowadays, every modern punya aircraft are use static inverters. So static inverters, my friend will continue lah. Alright, frequency control. Frequency control is controlled by varying DC motor speed. Frequency control ni untuk control speed. So when we lowering the field current, so we will increase the speed. Okay, figure on the right is one way of doing it by making this TR1 and TR2. To conduct it, we'll put R1 and R2 in series with R3. You understand? Or okay, tak apa, kita teruskan. A small PMG, this PMG mount on the shaft can be used to monitor the speed of the motor. This is used to control the frequency. Okay, so when we put this PMG, so we will know what is the speed of the motor. So we will control the frequency. So to prevent something like over speed or over current. Alright. Okay. Now we're gonna continue. What is a PMG? PMG is permanent magnet control, or also we call it as a permanent magnet alternator. Okay, so it is realized on the magnetic field generated by a permanent magnet to convert mechanical energy into electrical energy. You understand? That is what PMG. It can generate AC current, which is it can power the whole engine and charge the battery. That is what PMG. Permanent magnet permanent magnet generator. Okay. Torque switch. Torque switch. The figure shows a torque switch comprised of three-phase induction motor, a control spring, and switch mechanism. Alright, three-phase, like here. When the motor is running, the rotor will move the cam against a spring until at a normal running voltage, the contact are open. So this torque switch, when it's running, rotor will move the cam. So the cam will like this lah, will akan pusing macam ni. So until at normal running voltage, apabila pada normal punya running voltage, the contact are open. So when this cam touch this, so this contact will open. You understand? That's why we call it a torque switch. Okay, torque switch can be used to monitor rotary inverter output. The inverter failure will eliminate when low AC voltage, incorrect phase rotation, or phase failure of the AC output. I hope you guys understand. So we will continue to Haziq. So this is what rotary inverters. Haziq, you can continue. Thank you.
Assalamualaikum guys. Hari ni cerita pasal static inverters. So benda static inverters ni, static inverters dia menyupply, essentially dia menyupply current kepada instrumen-instrumen dalam kapal terbang masa enjin tak jalan. Enjin tu enjin kita dalam kapal terbang kan, enjin jalan baru current ada when dia supply AC power dekat instrumen-instrumen dalam kapal terbang. Okay, macam mana dia buat tu? Okay, first static inverter ni dia tukarkan current 28 volt DC direct current tukar jadi 115 volt alternative current. Itu dia untuk hidupkan instrumen dalam bertebak. Yang penting lah macam penting lah dia hidupkan, dia supply current dekat instrumen-instrumen tu. Okay. So ada yang tak tahu instrumen-instrumen dalam bertebak ni dia operate dekat 115 volt alternating current. So static inverters ni hadir untuk menukarkan 28 volt direct current tu kepada 115 volt alternating current. Faham? Okay. So static inverters ni bagus sebab dia tak ada benda yang gerak, no moving part. So dia akan kurang lah maintenance problem dia. Okay, berbanding dengan rotary inverters ni as korang tahu lah, wajib rotary dia berpusing, dia tak ada pusing jatuh. So bila benda yang banyak gerak dia akan ada isu maintenance problem lah. So dia akan jadi susah lah, sebab kalau kita nak kurangkan maintenance problem tu, so kita punya barang petebang tu boleh long lasting. So bagus dia sebab dia tak ada moving part. So next slide. Okay, dalam static inverters ni guys, dia ada internal circuit dia pula ada both, dia ada elektronik dengan electric component. So apa yang ada dalam circuit ni? Okay, so apa yang dalam circuit ni? Transistor, kapasitor, transformer. So macam korang tahu tadi ni, korang nampak dia tukarkan daripada DC current kepada AC current. So dia tukar kan. So dan korang nampak pun dia punya value tu jauh beza. So transformer arah kanan dia akan upkan current tu jadi berapa tadi? Kita lihat slide. Dia 28 volt tadi dia akan jadi 100 volt. Tu macam platform tu. Okay. So dalam static inverters dia ada oscillator circuit. Oscillator mesti korang boleh fikir, korang boleh faham. Oscillator ni maksud dia berputar. Macam tu lah oscillator dia bergerak. So dia akan develop, bila ada benda gerak dia akan develop frekuensi ni dalam inverter circuit. Jadi frekuensi 400 Hz. So daripada oscillator circuit tu dia akan produce 400 Hz frekuensi. Okay, faham? So as yang korang nampak tadi, current akan masuk, ada input. Okay, current masuk kata 28 volt DC, dia akan masuk melalui inverters ni, akan masuk, akan lalu circuit ni apa semua. Jadi dalam circuit tu pula ada transformer ni kerja dia filter current tu, dia akan tukar apa semua dalam tu lah, akan tukar jadi alternating current 115 tadi. Okay. Bila dia tukar dia akan keluar cantik kan, proper wave shape kan, voltage. So dia punya oscillate dia tu cantik pergi kan, tergabung lah, voltage pun cantik lah, 115 kan. So tak adalah dia damage kan instrumen kau yang kau bangun. Okay. Next, feature dekat static inverters ni guys, dia bagus kan. Okay, bagus dia sebab dia high efficiency, dia cekap lah. So current tu tak banyak hilang lah, dia masuk, dia dah filter, dia keluar pun cantik tadi engagement dia lah. Okay. So second dia macam cakap tadi, dia maintenance dia kurang sebab maintenance kurang daripada rotary inverters. So kita tak nak beli baru, nak fikir nak cost sekian, nak repair dia, tukar dia, tambahkan kabel kan. So low maintenance cost tu yang lain ni semua target dia nak kurangkan maintenance cost dia. Okay. Next, short warm up time. Short warm up time ni dia tak perlukan masa yang lama lah. Tak nak warm up lama kan, dia panas, so dia bukan heat lah. Dia bukan macam tu, dia kejap kau start dia, kau on je dia terus nyala. So tak payah, kita tak adalah banyak bazir masa dekat nak warm up kan dia ke apa ke, nak set up kan dia bagi cantik, kalau dia break tak senang. Kau on je dia terus jalan macam tu. So macam ni penting kan kau terbang lah, sebab kau nak guna benda tu cepat, kau nak guna instrumen tu at that moment lah kau nak guna. Sebab tu takkan kau nak tunggu je kan, kau nak tunggu dia warm up tu berapa lama lah kan, bila nak take off. Okay, so next dia quite quiet operation. Quiet ni masih ada senyap lah, dia tak dia macam cakap dia bukan rotary, so dia static, dia paling kuat pun dia juga dalam tu dalam static ni, dalam static betul sudi kat dalam tu je, so dia tak banyak bergerak, dia senyap lah. Next, quite quick response to work change. So quick response macam ni, current masuk, katalah current tu patutnya masuk 28, tapi tiba-tiba termasuk lebih 30, 32 macam tu, 4 kan masuk lebih. So static betul sini dia akan detect benda tu, tengok current tu, tak bagi masuk lah kan. Sebab bahaya, sebab nanti instrumen kau boleh rosak, instrumen kau boleh fault, rosak lah, rosak ni lah, banyak lah dia punya consequence. So quick response, dia detect benda tu cepat, dia tak bagi masuk lah buat tu. Kau setting 28, dia bagi masuk 28, kau setting ikut kau setting macam mana. Okay, next, principle of operation. Okay, ni kita lah, tengah ni jap. Okay, square wave oscillator. Okay, dia square wave oscillator, dia akan, okay, macam ni lah cerita. Current masuk, bila current masuk SCR1, SCR2 dia akan hidup alternately, macam dia berbalas lah, dia berganti-ganti, satu berganti. So oscillator output ni dia akan maintain AC output tu dekat 400Hz. 400Hz masa dia takkan pergi lebih lah, dia punya frekuensi tu takkan pergi 600, 700 tadi, dia akan stay 400Hz. So next is SCR1, SCR2. Okay, kalau kau nak off kan SCR1 dan SCR2 dia senang. Kau nampak kapasitor, kapasitor 1, kapasitor 2, kapasitor ni dia simpan charge. Okay, so bila kau nak off kan dia benda ni semua automatic. Okay, bila kau nak off kan SCR1, SCR2 dia, cara dia kau reverse bias kan kapasitor kau. Okay, bila kau reverse bias kan kapasitor kau tu, SCR1, SCR2 dia akan padam macam tu lah. Contoh bila dia tak payah kan. Okay, lepas tu kata lah bank tu SCR1 di tengah conducting, SCR1 tengah conducting, lepas tu masa dia conducting tu dia oscillate, dia akan charge kan ni, dia akan charge kan C1 dengan C2, kapasitor 1 sampai C2. Bila kapasitor 1 kita simpan charge. Okay, beralih pula dekat CR2, bila CR2 ni berfungsi dia akan conduct. Okay guys, sorry tadi ada gangguan sikit, tiba mati kan. Okay, sambung. Okay, bila CR2 conduct kan, dia conduct. Okay, turn dia conduct lah, dia oscillate, tiba-tiba kapasitor dia discharge kan current dia. Bila dia discharge kan current dia, dia akan reverse bias kan CR1. Bila dia reverse bias kan CR1 dia akan terpadam lah. Bila balik CR2 dia conduct. Okay, dia conduct ada oscillate. Tiba-tiba dia yang C1 dan C2 kapasitor ni dia akan discharge. Bila dia discharge, dia akan reverse bias kan CR1. Bila dia reverse bias kan CR1 ni akan padam lah. Okay, itu je yang terangkan dekat ni. Terima kasih. Assalamualaikum. Lupa subscribe.
Test. Okay, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Nasrul Muhammad Isa. So today I will explain about rectifier. Okay, what is rectifier? Okay, rectifier is an electrical device that convert alternating current AC which pedically reverse direction to direct current DC which flows in only one direction. So rectifier ni dia tukarkan alternating current ni AC ni kepada direct current DC, di mana AC ni dia boleh bergerak ke dua direction. Dua direction dan DC ni one direction. Tapi bagaimana? So, sekejap saya akan tunjuk. Sekejap lah. Okay, sekarang saya akan terangkan mengenai half wave rectifier. A half wave rectifier is defined as a type of rectifier that only allows one half cycle of an AC voltage waveform to pass, blocking the other half cycle. Half wave rectifier are used to convert AC voltage to DC voltage and only required a single diode to construct. Okay, so nak lebih faham. Okay, so half wave rectifier ni dia hanya membenarkan separuh daripada waveform daripada AC voltage ni melalui diode. So, dia akan satu direction sahaja. Saya akan terang graf. Sekejap ya. Okey, ini contoh circuit half wave rectifier. Okey, di sini kita ada transformers, diode and resistor. And ini wire macam biasa. Okey. Okey, current di transformers ini ialah AC, di mana dia boleh bergerak dari sini ke sini and sini ke sini. Dia bergerak dua direction. Okey, apabila output transformers ini, AC current ini melalui diode ini, current ni boleh lalu kat diode ni, lalu sampai sini. Bila nak patah balik, diode ni akan block. So, current daripada direction ni tak boleh lalu diode. Daripada sini sahaja boleh lalu. So, akan hanya satu direction saja. Sini saja. And sini tak boleh sebab diode ni block. Okey, input di transformers ini AC. Output. Sorry, AC ni graf dia macam ni. Cantik je. Tapi apabila current flow melalui diode, akan tinggal half saja. Yang bawah ni akan delete. Yang bawah ni kehilang. Akan tinggal positif sahaja. Inilah dipanggil sebagai positif half wave. Tapi kenapa dia separuh? Sebab apabila current di bawah ini nak patah balik, diode ni akan block. So, current hanya akan melalui satu arah. Only flow in one direction. So, from the AC current, it will change to the DC. So, daripada graf ini, dia akan pulsating, dia akan jadi macam ni. Tada! Okay, ini dikenali sebagai positive half wave rectifier. Okay, yang seterusnya ialah positive half wave. No. Ini ialah positive half wave. So, okay, kita akan sambung dengan negative half wave rectifier. So, berdasarkan slide, based on the slide, the difference between the positive half wave rectifier and the negative half wave rectifier ialah the position of the diode. Dan yang ni adalah position of the negative half wave rectifier. Dan yang ni positive half wave rectifier. So the difference between the positive half wave rectifier circuit dengan negative half wave rectifier circuit ialah the position of the diode and direction of the diode. Okay. So ini adalah half wave rectifier circuit. So sama macam positif. Ini adalah transformers. Ini adalah diode. Dan ini adalah transistor. Okay, sama macam positif. Di sini transformers menghasilkan AC current, alternative current. Dan output transformers graf yang terhasil pada output transformers ialah seperti ini. So ini ialah output transformers. Output ni di sini. So ini adalah graf . So perbezaan antara positif half wave rectifier dengan negatif. Yang positif, current akan flow melalui sini. Tetapi untuk negatif, current hanya boleh flow dari direction sini saja. Sebab apabila current ingin melalui ini, when current want to flow at this direction, diode ini akan block. So current tak boleh lalu. So dia boleh flow one direction saja. Apabila sampai di sini, nak patah balik tak boleh. Sebab kena block dengan diode. So daripada graf output transformers, sine wave positif, nilai negatif, dia akan menjadi, kita tukar warna merah. Dia akan menjadi seperti ini. Yang bahagian positif akan delete, akan hilang sebab current tak boleh flow sebab di-block dengan diode. So bahagian positif ini akan delete. So tinggal bahagian negatif saja. So ini akan delete. So akan resulting dan akan jadi begini. So konsep dia sama dengan positif half wave rectifier. Cuma beza dia, positif diode dia seperti okay, ini the position diode untuk positif half wave rectifier. Yang ni adalah negatif half wave rectifier. Okay, itu saja untuk half wave rectifier. Kita akan sambung dengan full wave rectifier. Sekejap. Okay, kita sambung dengan full wave rectifier. A full wave rectifier is a circuit arrangement which make use of both half cycle of input alternating current AC and convert them to direct current DC. So full wave rectifier ni ialah susunan arrangement circuit, susunan circuit di mana kita menggunakan kedua-dua half cycle. Kita guna positive half cycle dengan negative half cycle untuk menukarkan alternating current atau kita AC kepada direct current DC, daripada dua direction kepada one direction dengan menggunakan kedua-dua half cycle, iaitu positive half cycle dan negative half cycle. So kita go to diagram. Sekejap ya. Sini delete yang tadi. Okey. Ini adalah salah satu contoh full wave rectifier circuit. Besar sangat. Sekejap ya. Okey. Okey, ini juga dikenali sebagai bridge diode. Ini dikenali sebagai bridge diode. Okey, semua ni kita panggil sebagai bridge diode. Semua ni. Alright. Okey, so macam mana full wave rectifier ini terbentuk? Ini adalah AC current. So, ini adalah positif dan ini adalah negatif. Kita gunakan warna hijau. Alright. Okey, ini adalah current. AC current akan flow. Ni kita letak point A, point B, point C, and point D. Okey. Okey, ini adalah current, AC current akan bergerak ke point A. Okey, dan sekarang ada dua jalan. Kemana current ini akan pergi? Okey, so current ini, sebelum itu kita lihat dulu kedudukan diode. Diode ini ini diode. Apabila current melalui arah ini, current, diode akan on. Ini adalah forward bias. Ini adalah diode. Apabila current dari arah sini, dia akan off. Diode ini akan off kerana ini adalah reverse bias. So apabila current melalui diode ni akan on kerana current ini boleh melalui diode ini. Tapi apabila current melalui arah ini, diode akan block. So dia berada dalam keadaan off. Okay, so sekarang ini D1 in the on condition, but D4 in the off condition. So the current will flow from point A through a diode 1, D1, go to the point B. Alright. So now the current cannot go to the point C because diode 3, D3 in off position. When current through it, the diode will block it. So the current cannot flow through the diode 3. So the current will flow to the load, go through, terus mengalir. Current akan terus mengalir, and current go to the point D. Okay, and now current can go to the D4 and D2, but we need to remember the D4, the diode 4 in the off condition, so current cannot flow through it because this diode in off condition. So the current will flow from point D to the point C through the diode 2. and go to the supply, AC supply. So ini ialah positive half wave. Ini adalah positive half wave. Yang kita tunjukkan ini adalah positive half wave. Okay, so the AC has a two direction. So the current will go back to the positive. We clean it first. Wait. The full wave rectifier circuit, alright, this. So I will move it. Wait. Alright. Okay, we'll draw it again. This is a point A, we call it point A, point B, point C, and this is a point D. Now, this is A, this is positive, and this is negative. Alright. So the AC current, this AC current, will flow from the positive to the negative. And I'll draw it again. This is diode. I draw diode. Alright, diode. When current through it this way, the diode in the on condition, because it is the forward bias. This is diode. And when a current through the diode this way, the diode will block the current, and the diode in off position condition, and this is called reverse bias. Alright, so we need to remember, this is on, this is off. Okay, we red one, blue, the blue one. So the current will flow through this, and go to the point C. Now, the current have a two-way. It can go to the diode through the diode 2 and the diode 3. But we need to remember, the current cannot flow the diode through this way because the diode will block it. And so the diode in the off condition. So the diode block the current. So the diode 2 in off condition. Off. So now off. Alright. So the current will continue this way through the diode 3. So because the diode 3 in the on position, from the point C go to the point B. And now the current cannot go through the diode 1. Why? Because the diode 1 in the off position, and now the current cannot go through the diode 1 because the diode 1 in the off condition. And when current want to through it, the diode will block the current. So the current will go to the load from the point B through the load, go to the load, and go to the point D. And now the current can go to the diode 4 and the diode 2. The current from point D can go to the point A and the point C. But we need to remember, diode 2 in the off condition. So the current will flow from the point D through diode 4 go to the point A. Okay, and now the current the current can go to the point B, but it cannot because diode D1 in off condition. Typo. Off condition. So the current cannot through the diode 1. So the current will go to the supply. So I will draw a graph. So that is the negative half cycle. And the positive half cycle, the first one, the first circle I show you sebelum ni ialah positive half cycle positive half wave rectifier. So now this is called as a full wave rectifier. Why? So we go back to the slide. So a full wave rectifier is a circuit arrangement which make use of both half cycle of input alternating current AC. Of input alternating current AC and convert them to direct current DC. So kita menggunakan kedua-dua half cycle AC bertukar menjadi DC. So that's all, full wave rectifier. So we done a full half wave rectifier and full wave rectifier. So that's all from me, a rectifier. Thank you.
So now we continue with AC ripple controls. As we know, to reduce the ripple, we can use a static machine auto winding transformer which transfers electrical energy from one end to another without changing its frequency. Other than that, output must be connected in parallel as shown in the next figure that we will show after this. This arrangement gives an output with ripple frequency of 12 times the input. This will reduce the magnitude of the ripple. So this the gambar. Okay. The protection. If the transformer rectifier unit increase, damage can occur to the diode because of the heat. And because of that, the overheat thermostat can be fed to give a warning to remove the AC power from the transformer rectifier unit. Residual current circuit breaker, or we can call RCCB, also can be fed to prevent DC bus bar pull down when transformer rectifier unit has an earth fault. So this is a gambar. So diode. The function of diode to increase the current capacity and reduce the heat effect. The diode also must be connected in parallel. Ratings, output voltage and maximum current ratings, the label. So this is a diode. And lastly, the maintenance. Ensure the TRU has adequate cooling and ducts not blocked. Ducts not blocked maksudnya macam jangan dia punya salur jangan ditahan. And number 2, ensure cooling airflow in the right direction. Number 3, check that electrical connection are secure. Number 4, functional test the overheat circuit. And number 5, functional test the transformer rectifier unit, or we can call as TRU. In the end, thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good 10:40 p.m. evening to Sir Hisham. Today I'm going to be presenting a topic that is given to me and by my group. The topic that I was given, a subtopic, is the transformer rectifier units, also as known as TRU for short. So the TRU is a unit that is found in aircrafts, and it plays a very big role in the function of an aircraft. So now I'm going to start with the function of the TRU. So the primary function of the TRU is to convert an AC power to a DC power, which is alternating current power, to a direct current power of the aircraft or the unit. A TRU consists of a transformer and a rectifier at the same time. Therefore, thus the name, the TRU, transformer rectifier unit. The transformer and the rectifier, the TRU, the transformer inside the TRU is a step-down transformer, while the rectifier changes the power to DC power. So basically, obviously as it states that the transformer is a step-down voltage, so it steps down the voltage inside the unit into a smaller or lower voltage level, while the rectifier, of course, changes the power to AC to DC power. The TRUs are very lightweight, and they are mostly used in military aircrafts and commercial aircrafts. In military aircraft such as the A400M, which is normally used in our country, the military in our country, it's a big aircraft which holds the cargo, can bring vehicles and all that. And commercial aircraft such as the Airbus. Right. The model of the TRU that is frequently used in the market for military aircraft and commercial aircraft at the same time is the electrocute model TR1010. That is the model that is always used and frequently used. Alright, next is the cooling process, which is very important for the continuous function of the TRU. A constant use of TRU will cause overheat. Therefore, we need a cooling process or cooling way so it functions normally and functions efficiently. There are various ways to maintain the coolness in the TRU for efficiency, such as the TRU. It has a fan built inside already, and the built-in fan inside the TRU is powered by the unit's AC power supply. So that's the thing. If that confuses some people, the power supply of the unit is an AC, but the rectifier changes the AC to a DC. Yes. Also, the central cooling system that passes through the TRU. They have a central cooling system that passes through the TRU of the aircraft, such as also, yes, sorry, apologies. Basically, let's say that the central cooling system is outside TRU, but it still passes through the TRU, therefore cooling it inside. Some cooling is provided by the thermal conduction by the mounting base plate. No forced air cooling is necessary. The absence of blowers results in high reliability and absolutely maintenance-free operation, ensuring a low unit lifecycle cost. And lastly is using natural heat convection to the heat sink used by low-rate TRU. These are some of the third point. I found it online by a reliable source in a military website. Alright, finally the AC ripple. Sorry, it's not going to where I want to go. Alright, and alternative current ripple in the TRU. An output that is twice the original frequency is produced by the single phase full wave rectification as shown in the diagram below. As you can see, it's a full wave rectification and it's twice the original frequency of half. Alright, and finally, the diagram as here that I got from the slides. The diagram shows a full wave rectification of a three-phase supply. It is shown that the ripple has reduced in a large amount and the frequency is 6 times of the supply. So before this it was a single phase, but finally for the three phase it's 6 times. The frequency is 6 times larger than the average supply. Alright, so that's all for my part on the presentation, and the next part will be transferred to the next presenter. And thank you very much for your time, sir, and enjoy the video.